So what we have is a parallelogram given, and we're going to prove it's a rhombus. They're giving us AC is the same as BC again, and 1 is the same as 2. Okay, so let's start with that. Angle 1 being the same as angle 2 is given. Now, the move we can make from that, and I am going to skip a step here, is I'm going to say EC is congruent to CB by base angles theorem. Okay, we could say converse of, basically these two angles are congruent. That leads us to the sides opposite those are congruent in that triangle. Okay, so now what we're going to do is we're also going to say, wait a minute. Yes, I've got to connect this one as well. Okay, since AC is congruent to BC, because it is given, okay. All right, now we got to mention that ACEF is a parallelogram. All right. Now, let's see. Kind of bouncing around here. I should have probably, right after these two, used the fact that AC is congruent to CE, and that's combining these two right there, and that's by substitution. All right, now 6, I'm going to jump right to ACEF as a rhombus. And I'm going to explain this because a parallelogram with adjacent sides congruent must be a rhombus. Okay, good enough. All right, so we have a rectangle. So all the angles are 90s. Midpoint, let's see, we're trying to prove that XM is congruent to SM. So I'm looking at it like this. I'm going to prove the triangle's congruent by side angle side, and then I'm going to get these XM congruent to SM by the corresponding parts of congruent triangles kind of theorem. All right, so let's start with, might as well start with XYRS is a rectangle. Let's just combine those givens. And M is the midpoint of YR because it's given. All right, I'm going to say, I'm not even going to say right angle, I don't need to. I'm going to say angle Y is congruent to angle R because all the angles in a rectangle are congruent. So I don't have to go through the process of them being right angles. I can jump right to that. YM is going to be congruent to MR by definition of midpoint. So that's why we marked YM congruent to RM, because they said M was the midpoint of YR. All right, we already said it's a rectangle, so we can jump right to this. XY is congruent to SR because opposite sides of a rectangle are congruent. So then 5, I finally have the triangles congruent, so XYM congruent to SRM by the side angle side triangle congruence theorem. And XM congruent to SM by, I'm going to write it out, the corresponding parts of congruent triangles are congruent. Okay, let's keep going. Number 4. Oh, rectangle again. Interesting. Okay, now we do have to talk about right angles. All right, we'll get these triangles congruent, and then we'll say these are the same. So it's a little different process. Okay, so again, 1 XYRS is a rectangle. All right, and XM congruent to SM because it's given. Okay, that gets us a pair of sides right there, specifically the hypotenuses. So actually it's going to turn into an H because we're going to use hypotenuse leg. All right, a little different approach now. This time I'm going to say angle Y and angle R are right angles. Because all angles of a rectangle, or in a rectangle I could say, probably better, are right angles. All right, so now triangle XYM and triangle SRM are right triangles because they have a right angle. You could probably get away without this step, but I like it. I think it makes it more complete. You know, I'm going to use hypotenuse leg. I should kind of establish the fact that it is, in fact, a right triangle, so that I can use the idea that it's a hypotenuse. All right, so we had a pair of hypotenuses. We got right triangles. XY is congruent to SR. That's again because opposite sides in a rectangle are congruent. All right, let's see. We've got a pair of legs now. So hypotenuse leg is ready. So triangle XYM congruent to triangle SRM by the HL triangle congruence theorem. And we're not quite there. We actually need 2 more steps. Okay. Now YM is going to be congruent to RM by that corresponding parts concept again. Of congruent triangles are congruent. And now we're going to say M is the midpoint of YR by definition of midpoint. You know, both halves here are now the same. So M must be the middle of that side. Okay, let's see, good enough for this video. Again, we'll do the next 3 or 4 and then